Good morning. My name is Steve Wall, and this is Magellan at Venus. Everybody continues to be in an excellent mood nowadays because things are going very well. And with only a slight finger cross under the table, we continue to map Venus every 3.25 hours. You take another small strip down the planet, continue to put them together. We'll talk a little bit more about that, and then we'll talk about all of those strange parallel lines that we've seen in just a couple of minutes. Right now, Magellan is in its 499th orbit around the planet Venus, 55 minutes past apoapsis, which means that it has just finished a playback toward Earth and is ready to make its turn to line back up on its next pass, carefully aligning the images so that they just overlap, but not too much, so that we continue to build our map. Currently, we are 159,119,878 miles from Earth. That's 256,78,000 and a little change kilometers. Above the Venus surface, we are 8,450 kilometers. That's 5,281 miles. With respect to Venus, we're traveling at 11,580 miles an hour. That's 13,295 kilometers an hour. And it takes light or commands or data of any type 14 minutes and 14 seconds to get from the spacecraft to Earth or the other way around. You'll notice that we are getting just a little bit longer each time as we get toward the superior conjunction period, when the Sun, the Earth, and Venus, and of course Magellan, are in a straight line. During that period of time, we will have to stop our map for a few days as the Sun actually gets very close to directly in the way of our telemetry. We'll stop for a period of time we haven't quite figured out yet. That depends on exactly how active the Sun is, but hopefully it will only be a few days, at most a little more than a week, and we will then pick up right where we left off with a small gap, and we'll continue to make our map. As I told you a couple of weeks ago, we have now certified our ground computer, the computer that puts these images together, whereas with the preliminary images you may have noticed, and we certainly noticed, that there was a little shading at the edges. Things were not quite adjusted correctly, and so we weren't making any of our big mosaics except just as tests. What we've been showing you so far, and actually what we'll show you today, are test images. But starting this week, we have begun to put together the real mosaics, the big square images that you've seen. We'll put these together until we build up an entire planet's worth, at which time we'll have a global map, which is what we've been looking for all along. Magellan is taking mapping data now from its 235th orbit of data collection, 235 of these little stripes that put together these big pictures, and we'll continue to put those together, continue to make the map as we go along. Speaking of the map, one of the things that everyone has noticed who's looked at the pictures have been strange sets of parallel lines that look almost like somebody took their fingers and scratched across the surface and made little grooves or ridges or whatever they are. So today I've asked George McGill from the University of Massachusetts to come and talk to us about what those parallel lines mean. George, it must be exciting to look at this stuff, but it must be also awfully frustrating to try to make sense out of all of this.
It is. The number of lines is almost awesome. I think we anticipated seeing areas with lines from the ground-based information we had before, but I think all of us are surprised at how abundant these things are, particularly in the sort of dark areas that showed up on the older images where we didn't expect to see so many.
Well, now you saw some lines in the Arecibo
That's
images
right,
and in the Pioneer Venus data, but there's even more now, right?
Absolutely, yes.
Show us some of them.
Well, and this is one of these mosaics you were talking about.
Okay.
It's about 15 or 20 orbits worth, I think, something like that, put together into a mosaic. In fact, you can see a little bit of striping up here where the individual orbits don't fit together too well. Right. So those lines don't mean anything.
Right.
Real bright lines like these did show up on the Arecibo data, and so we're not too surprised at those. But in the areas like in here, there's some very faint lines, like there's one. There's a whole family of them going like this. And these, I think, were maybe not necessarily unexpected, but I think we're sort of surprised at how abundant they are and how many different sets of them there are.
What do straight lines mean?
Well, they can mean a number of things.
Okay.
I don't think I could even tell you what all of these straight lines mean.
Okay.
One like this, for instance, all we can really say is that the radar is returning more energy from that line than it is from the areas around it. Now, that could mean that the surface is a little rougher along that line. It could mean there's a little bit of topography there, that it's bouncing off a or the material could be different.
Okay.
It's hard to tell. Probably it's rougher, but that's somewhat of a guess.
Okay. One thing that's particularly surprising is they're not just lines, but they're parallel lines.
Some of them are, yes. There's in fact, I think I would like to talk about a set that I see here,
Okay.
which is a very dramatic set. This is a good place to see it right here. We see two parallel lines defining a structure, and you can see that these lines are abruptly truncating a pattern that exists in the surrounding area.
Looks like they cut them apart.
They really do. It cuts it apart, and that tells us that whatever this structure is younger than this material here and here. It gives us a chance to do a little bit of deciphering things by time.
Okay, so you know that these lines came first.
That's right.
And then something happened to
sort of cut them off.
Okay.
And this, in fact, is, I've run some topography or some altimetry tracks across this, and this area in here is lower than here and here.
Okay.
And this then is what we would call a graben.
Okay. What's a graben?
Well, a graben is a structural valley or structural depression, and in fact this is a little sketch here maybe will illustrate it. If you can imagine taking the surface of the Earth or Venus or any other planet and sawing a big slab out of the crust and lifting it up in the air, we're looking at the land surface here and here and here, and the vertical sides of the crust from down inside the Earth.
Okay.
And this is a graben. And it's a valley on the surface, but it doesn't get there by erosion, like the Grand Canyon, for instance.
Okay.
It got there because the rock, the crust within that strip, actually physically dropped.
Just fell down.
It went down,
Okay.
and as you can see by the slope of the faults or breaks in the rock that bound this graben, in order for that to go down, this has to move this way, and that has to move that way.
Okay.
So this kind of a structure implies a stretching or extending of the crust.
Okay, let's see. I'm familiar with the drive from here to Mammoth. And a lot of people have gone there. You go up a valley called Owens Valley. That's sort of a graben.
I guess that's true. I don't live here. I live in Massachusetts, right in the middle of another graben.
Is there one there?
Connecticut Valley graben, which is a couple 100 million years old,
Okay.
and 20 or 30 kilometers across, 10,
Okay.
15 miles across.
Okay. And just for people who know cities and things on the East Coast, how
Well,
would
Hartford and Springfield
they are in the middle of this.
are within the Connecticut Valley graben.
So this is a big block.
Yes, it
Ooh,
is.
huge
Yeah. They can be of any size. They can be very small to very large.
Okay. But this implies something that happened under the surface.
Well, yes, the surface material has been extended.
Okay.
Now,
so
in terms of sizes, this one is about 6 miles across. The way
Okay.
I was pointing to here.
Okay.
Now, what I find interesting about it is that it shows up very nicely here, where the older material is there. But we follow it out here. I don't know how well this will show up on the television, but out in here, you can see faint white lines, almost like railroad tracks, coming along like this, and another set going this way. And if you follow this set going like that, lo and behold, here comes the graben back up to the surface again. So out here, I think this graben structure is buried beneath younger, darker materials, probably lava flows.
So this whole thing, this whole valley, if you will, goes for several hundred miles, right?
Yes, probably. That would be
Okay.
at the scale here, that's less than 200 miles, but it may go farther.
Okay.
It's hard to say. And there are others of these. If you look around, here's another one. Shows up very clearly here, and then you can see the faint ghost of it sticking out
Right.
here. And there are more over here.
Yeah.
Here and here, and in fact, we can see a pattern of these, as I was indicating a little earlier, swinging around here.
And maybe even more.
Probably. Yeah. Now, what I find interesting about this as a geologist is that this suggests to me that there is a basement made up of material like this underneath the dark material out here.
Okay.
The graben cut that basement material, and then later it was buried out in here.
Okay, so we've got 3 time events now.
That's
We've
right.
got this guy, the lines that are
Right.
parallel that come across. Then we've got this thing that happened.
Right.
And then even later, whatever this stuff is,
Yes.
flooded in or blew in or whatever.
That's right. And then we can go on, because some of these lines that you started out pointing to the beginning,
Right.
at the beginning, like these here, are again faults, or some of them are grabens, I think. Others are probably faults or fractures of different kinds.
Okay.
These are clearly cutting this dark material here. So that's another event. And this one represents an even different event. It's a little hard to demonstrate that here, but I think that's even younger.
Okay, so we've got 3 or 4 time sequences. Is there any way of telling in absolute time how how far apart these were, or how
No,
close
not now,
together?
I'm afraid. It
Okay,
would
so
be
this
nice.
could be millions of years old. It could be thousands of years old.
It's thousands is probably unlikely. Geologists tend to think in millions of years rather than thousands.
Okay.
But whether we're looking at structures that are a few million years old or a billion years old, there's no way to tell at this time.
But the interesting thing is that you can tell something about what happened under the surface, which you can't see, and you can really even maybe interpret what happened sort of under the surface just from surface
That's
experiments.
correct. This is what I think, this is one of the contributions of geology to planetary science. We put the fourth dimension, or time dimension,
Right.
on events on the planet.
Gee.
And this sort of an analysis is a very small example of predicting what's in the subsurface and predicting a sequence of events that has affected an area.
Well, how many of these things do you see? I mean, if you look at other frames, do you see these things going on?
I've seen suggestions that these buried grabens continue southward down this way into the next mosaic, and then possibly into the mosaic south of that.
Okay.
And if true, it's a little uncertain, but if it really is true, then it seems to be defining a very large circle, some hundreds of kilometers across. I haven't actually measured the diameter of it. I think at this point I would like to just wait and see what is over here.
Any clue as to what's in the middle of the circle?
No, we haven't imaged it yet.
Wow. Wow.
The craters of the crater farm, I think you've probably shown those on an earlier
Right.
show, are right just below here, within the circle. But that
Okay.
may be a coincidence. I suspect that that's just a
Well,
coincidence.
the craters were probably, or certainly caused by something external.
That's right. They're impact craters. This is due to some kind of an internal process, probably, or an internal process modifying an impact structure. That's uncertain.
In the area that where we started mapping, just to the east of Beta, there are lines that seem to be sort of radial, coming out from the big continent-like structure. Is that also evidence of something going on underneath?
Well, Beta, these are lines that came out from Beta.
Right.
Those Beta is, of course, an elevated region with
Okay.
a very large trough, much larger than this one, in the center of it. And they probably are responses, mechanical responses to the stretches that were put on the crust when it was uplifted.
Now, you will eventually take all of this data back home and sort of pore over it for a while, right?
Yes.
What kind of, there's a large department at UMass that does this sort of stuff. You're going to be sort of their envoy and take it back and...
Actually, we have a fairly large department of geology and geography at the University of Massachusetts. There aren't too many of us involved with planetary work. Off and on, there are 3 or 4. I'm the primary person right at the moment with some students.
And what in particular is your field?
I'm a structural geologist, which means I'm involved with the bending and breaking structures in rocks, such as the graben.
Such as this kind of thing. What does this tell you about the nature of the material, the nature of the rocks?
The fact that it has all
Yeah,
these...
the fact that it's a graben and that it's so big. And
Well, it has to be at least brittle enough to break rather than bend.
Okay.
That much it tells us. And although I haven't done the analysis yet, sometimes one can get a clue as to how thick the brittle layer is from the geometry of these things. Because eventually, if you remember the little cartoon sketch we had of a graben, the faults bounding these things slope inward towards each other.
Okay.
At some finite depth, they have to meet.
Oh, okay. All right. So it can't be any thicker than that.
Well,
sort of
that's a clue
angle.
to that meeting point is probably mechanically controlled. There's probably some reason why those bounding faults meet at that depth.
Right. But I guess the overall thing you're trying to do is to get the big story. You've been telling us sort of little stories here.
That's where you start. Yes.
That's where you start. So very interesting. Thank you, George, for taking the time to be with us. We'll continue to take more pictures and look at more pictures and try to give you a glimpse into what the explanations are, the things that make us understand what Venus is about as we go on with Magellan and Venus. I'm Steve Wall, and we'll see you next week.